So this talk is bridging the research practice gap towards innovation algorithms and qualitative functions of domain-specific design scenarios. Or, what does that wallet exercise have to do with me? I'll explain what these things mean, of course, in the course of the evening. I think you all know what the wallet exercise. Who doesn't know what the wallet exercise is? Here. Okay. So oh, really? The wallet exercise. Wallet exercise, I love that. I know something you don't know. It's great. The wallet exercise is basically a little toy exercise we give in order to get people rolling with design thinking, in which you basically interview someone and then redesign a wallet based on that. Okay. So, I want to say thank you for coming and welcoming me. As I said, Professor Meinl, quite apart from having anything to do with appointing me, has been enormously generous to me, and I'm very grateful for that. He does have great vision. I'm so happy to be working for an extraordinarily intelligent leader. Thank you, Uli. And Claudia, where are you? There you are. Hi, thank you for welcoming me and making me welcome here and weaving me in so quickly. It's been really great. Elizabeth. Moving to a new country where you don't speak the language can be pretty daunting. One thing after another. Elizabeth has been there with her van, helping us pick up stuff, coming to me to the Brandenburg offices where I have to fill stuff out and I don't know what it is, to helping us find a school, to helping us find a place to shop. Everything has come through Elizabeth. She's been such a good friend. Thank you. And I could name everybody, but please suffice. I'm talking about all of you. Thank you for having me. Uli invited me to give an informal talk about what was new to me and what I'm thinking about right now, and I took that very literally. So this is all wet on the page still. Don't expect this to be like I'm telling you science here. This is really, really new thinking for me. And it was inspired by being in this community. But I want to tell you something else that's new to me. I'm getting help in German here. So I have these great phrases like, Das Leben ist kein Ponyhof. I've used that in the wrong places. Oh, this one I also like. Hey Leute, was geht ab? One of my colleagues said, you sound like a drunk guy on the train. But that's an improvement. We have more in just a minute. So, having recently and happily arrived here, my thinking has been awakened and energized by this vital and diverse community. I'm deeply grateful for this opportunity to share my thoughts and to work with you. And what follows is a work in progress. I have no solid answers to the excellent questions I've heard in the past few weeks, though I have this nagging sensation that's familiar to me when something new and big and alluring and absurd, and you'll see that it's a little absurd, possesses me, keeping me up at night, wanting to come into the light. It's the beginning of a new vision. So, who's here from research? Okay, raise your hands high. This is good. Okay, hi. Good. Yeah, I know you too. Yeah. And who's here from industry? Is there anybody from industry here? Great. So we have some industry. Oh, that's great. I'm not striking out entirely. I have to say that this talk, somehow in my mind, I thought was going to be more directed towards people in computer science. Is anybody from computer science here? Thank God. Otherwise, we got to change this. We'll just play tunes. Okay. Professional practice. That is, you do, yeah, professional, yeah. Design theory and methodology. Anybody from that? Oh, good, we're reaching it. From the D-School. Yeah, look at that. From the academy. Way. Yeah. Now, I have a feeling there's a lot of overlap in these things. Who here is curious? all these hands should go. If your hand doesn't go up, why are you in a university? Why are you a designer, right? Okay, so here are some questions that I've heard. There are 4 questions that So it seems to me a lot of what we're trying to go to, not everything in an institution like this, is what they call the technology of epiphany, where you have new tech and radical change in meanings, that is, things that have to do with people and what makes their lives better, come together. And I think we're in and this is from Rick Ante, I think we're in a unique place to do that here. And it doesn't just have to be this, but the whole idea of digital transform is everything about this. That is, as Professor Miles says, it's a huge opportunity, not just to make apps and put what we got already on a server, but to actually redesign it, because it's a huge infrastructure change. So, question 1, what does the wallet exercise have to do with my practice? It's a tool to introduce people to the practice of design thinking that could be applied to other redesign scenarios. But there's still a gap. Just how does that happen? How would that work? Question 2, what does design thinking have to do with my organization? The question I've heard again and again. These questions I've heard again and again. And design thinking is a decoupling of design from any specific tool set and recognizing that the process can be applied to any problem space. But that leaves us still with a gap. Doesn't really answer the question of how that works. And then what does theory have to do with design thinking? Because design thinking is really this practice. It's a collection of these tools, and we practice them, and that's where the expertise is. And I can say that through grounding practice in empirical and scientific evidence, design theory and methodologies provides rigor and insight so makers of change make impactful and informed choices. But we still have a gap. It doesn't really explain anything. And this is the last question. How can research be made practical to bring value to my organization? And implementation of fundamental research has the potential to make positive impact for people across the world. But again, we are still left with a gap, with a problem. And tonight I want to talk about how we bring together those gaps. So here are the research questions, or the discussion questions. I can't claim this is real research. Notice I just put a Q, not an RQ, right? And I'm going to kind of pull all these together, because I think working together, the people in this room can create manageable, understandable steps across these gaps. And through doing that, we can bring a lot of value to the world and also have really good jobs. So the first one is, what does the wallet exercise have to do with my practice? This is something, right, this is something we hear again and again and again, right? In the academy, we hear this. I didn't make up these questions. These are things, right? So, again, it's this tool that we bring in to teach just basically how we do it. But the gap remains. So here's the wallet exercise. Step 1, understand what is the world of wallet and wallet users. 2, observe, interview and observe a wallet user. 3, with your data, compose or propose a user and a need, that's a point of view. Then come up with generous array of notions for new wallets. And make a generous array of, I didn't finish writing that, I'm sorry to say, but make a whole bunch of prototypes, right? And then you give it back to the user, and you test it to get feedback. And you observe, and you repeat it again and again and again. So here's some from a recent open course at the Academy. Who was there at the open course? Anybody here at the Academy? Oh, you were. Yeah, that's right. You ran it, right? So here's some of them. And to those of us who are initiate, we know what these are about, and we can make sense out of them. But people who aren't deep into this have trouble making sense of what they're about. But in order to... Did I go in the right direction? Sure did. I'm going to enlist design theory and methodology. I'm going to make the problem a little bit bigger. So in ecological systems, if you want to study the fish, you have to study the pond. So I'm going to look at the pond right here. I'm going to go out a little bit and bring this. So here's a Greek word. I've been told, watch out for these Greek words. But a dolomenon, a created thing that manifests knowledge or a rationale. The products, services, and systems we create contain knowledge, right? They contain knowledge. Those wallets all contain knowledge. And this is a word which comes from conspicuous or to manifest, to disclose, a thing that discloses. It shows what the knowledge is. I made it up. So these objects are delumina because they manifest several kinds of knowledge pertaining on the disruption of something that exists. Right? Wallets exists, and we change them with this new knowledge. And the new knowledge is the stuff we get from users when we watch them and talk to them about what's going on. So, in this case, it's the why, for what, when, and for whom of a wallet. I know that sounds a little abstract, but when we talk to a user and we say, so what do you actually do with your wallet? Where do you use it? Who are you? We get a user. We find out what they're doing, right? That's the why of that wallet. And when we know that, we don't get generic wallets, as nice as they may be or not. We actually get some really interesting specific stuff that contain the knowledge. Okay? So, another way is an understanding of people, how people think and act with a representation. That is, when we use these rough prototypes, something else happens than would if we use just regular wallets. And I'll tell you about that now. This is a framework I developed, and it's abstract to concrete, poorly defined to well-defined. Right? When we say rough prototypes, there's something over here, and the fine prototypes are over here. All right? This is a simplified version of this. So here's an example of a rough prototype, the kind of thing we'd make here for some kind of device. And that would go down here. It's poorly defined and concrete. There's another one that would go there. This is kind of these concept sketches we do. It would go up here. This is kind of stuff that we do when we're doing research. It's very carefully resolved. And the same thing with process models or CAD drawings, and they go up here. And these kind of models like this or this, you know what this is? You can't drive this car. You know what it's made out of? Clay. They're really expensive. But what they do is they actually help us understand, because the CAD models don't tell us exactly what this radius is and what this edge is and how it works. You need to have a big, they spend a lot of money because they need to see what that's about. So these are the different models we use, and we think differently when we use them. So this is some of the thinking that we do. I'll simplify it here. So the whole thing is, thinking doesn't happen in your head alone. We know that as designers. Thinking happens with our bodies, with our minds, and the stuff we play with, right? You think differently with one tool than you would another tool. So these ones have what we call logical status, meaning they say, I'm a real thing. Don't mess with me, I'm real. It is pretty tough to get someone to make big changes when you give them stuff like this. And I know this from research. It can happen, but it's tougher. Whereas if you give them stuff like this, we don't talk about just what kind of surface is that. We talk about what are the situations this would be used in, what are the different ways we can change it. These things don't say I'm real. These things say, move me along. Okay? They say, move me along. So, the question is it possible to use this framework to translate models that afford behaviors that allow us to make change rather than to nail something down? This is where we nail it down. This is how we do it. And in fact, so how can we translate this stuff into this? And we can do it. We start with a CAD model. We can make rough sketches from it. We can make a metal thing. But I promise you, this metal thing and this won't give you the information that this will. This was done at Stanford. It's a car that's made out of wood that doesn't go anywhere. You see the wheels aren't attached. And it was a design for a research model. And the idea of it was that better than this or this, because you can't move this really well, but this thing you can move around because it just comes apart. This you can't sit in, but when you sit in this, you can start finding out things you'd never think about. It'd be very hard to think about. For example, someone sitting in and going like this, and it's a drive-by-wire car, so there's no mechanical linkage that steers the car. It's all done via servo sensors, right? Someone did this. Well, yeah, if it's that, we can just hand the steering wheel. Here, you drive now, right? And it was because they were in the car. It would have never happened. Another thing that happened, so where the rubber meets the road is everything in vehicle dynamics, that in the suspension system. When they built it, they realized by sitting in this, they couldn't see the suspension system. So what they did was they said, you know, it'd be really helpful if you could see it. Whack, 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 whack. You know, a saw, a hammer, boom, it was gone, and they could see it. Much easier to do that here than in this one. So these things, these rough prototypes, which are really the same thing as, and there it is, and that's a guy named Dave Baggerer. He had worked for a long time at the D-School at Stanford. He was a great guy. So here's another example, and this is from, anybody know Alexander Lube now, Grosskopf? Yeah, you do. And Matthias Veska, and I was engaged in this also. And it's, oh, there I am. What we did was we used this framework to take business process models and make them physical, so lots of people could use them and move them around. So these things have a lot of, those have knowledge, these have a different kind of knowledge, and this is knowledge about how you make something so it can be changed. And in fact, people start reacting very differently to these things than they do to spreadsheets on the wall. They move them around, they write them, they change them. So, these things have lots of knowledge in them. They're Delomina. That's another reason why we use them. Oh, so with the wallet, we've actually gone from this very well-defined concrete thing to this concrete, loosely defined thing. It certainly is a little more abstract. When we move these forward, we move into these directions, right? Eventually, if we're going to manufacture it, we'll probably make a CAD model of it so we can have it manufactured, because those are instructions. Probably do some of these drawings, and we'll make some final kind of nice prototypes out of it before we ship it off. It's also a highlighting tactic for drawing out important behaviors, right? And I mentioned that before. When you give the model back to someone, that kind of bubbly, weird wallet, we watch what they do with it, and they're going to behave with it differently than they would with a regular wallet, because it's not so contained. It's not so well defined. It doesn't say, I'm this thing, you can't move me. And it's a strategy for quick iterative learning. You can make one of these janky wallets, one of these wallet prototypes, in a couple of seconds. You can make another one in a couple of seconds, and another, and another, and another. And there's no labor lost. You won't lose sleep on that, because you'll just make them and make them and make them. Right? And so they're a vehicle. So in that way, it's a Delomenon because it manifests knowledge about design, people, and how new knowledge is created. So what does that have to do with this? By the way, this is not the wallet. This is the problem. That's the wallet over there. Their problem with this one was, my wallet is so kind of, you remember this? It's kind of puffy. It's too big. Well, we got to shrink it down into something. So now that we know what kind of knowledge it manifests, we can create all sorts of artifacts that serve the same purpose, whether it's business processes or coffee or the noodle exercise, which we just did, or going to the doctor, or any kind of treatment, anything at all, we can reduce in the same way to that kind of model. And that allows us to iterate very quickly. It allows us to see behaviors and get new knowledge about it. Now, you guys knew all that. It's a fancy way of saying this. We disrupt by asking the why for what and the whom of it. And that is the stuff of human-centered design, right? We want to know who's using it and why, who's engaged in it, how does it make them feel, what does it allow them to do. So the wallet exercise is a pretty good model for us to copy and extend when you want to bring disruptions grounded in human-centered insights and offerings to your practice or organization. So if you're a geologist and there's a new tool or a new thing, you can just start getting some cardboard and paper and putting that together, and you can create something new and try it and see how it works and play with it. If you're a doctor and you're working on a new treatment, you can do the same kind of thing, but don't do it with people, because you could kill them. So now we have a sense of how this works. So informed prototyping is a powerful start for making change in a product, service, or a system. Still, to make change, you need more than a few good prototypes. You need an organization that has quantitative and qualitative capacity for making grounded disruptions and mechanisms for integrating these disruptions. So that brings us to the next question is, what does design thinking have to do with my organization? So we spoke about this before, that is, the process can be applied to any problem space, but it doesn't really answer the question. So this is a generic new product development model. We start with ideas and market research and marketing. We screen the ideas. Does it fit with my strategy? Is the idea good? What's the return on investment? Is this trending now? We evaluate the ideas. We test the concept. We ask customers, and we estimate costs and profits. We do product development, research and development, We make prototypes, market tests, we make revisions, and then we send it off to manufacturing and marketing. And that's the regular way this thing is done. And I want to notice, you to notice it starts with ideas and market research. Now, design thinking, ideas are secondary. We talk a lot about how ideas are, but we really don't use ideas so much. What we do is we look at people. We understand users. We explore. We see what the possibilities are before we come up with ideas. And very often we come up with some prototypes before we come up with anything we'd call an idea. Now, design thinking disrupts by introducing new objects, behaviors, and narratives into traditional organizations. It replaces this. It doesn't replace this. You can use design thinking here, but in terms of just a really simple in, we're getting rid of this and putting this here, and what we're coming up with is a grounded, tested thing that responds to people's needs. So it goes like this. Now, by doing this, we reduce risks, we increase customer satisfaction, engagement, and we lower development costs, right? Because it's really cheap to do this stuff that I just talked about. It's really expensive to make really perfect working models and roll them out to people, right? That car, you know, that's hundreds of thousands of dollars for the clay car. We don't need a clay car. We just need some wood and some wheels. We're there, right? It's much cheaper to do that and quicker. Still, the gap remains. So again, I'm going to enlist design theory and methodology because that's what I do and where I come from in order to see how this actually works. So far we've talked about making disruptions, but now we want to talk about making integrations, because how do we get that to work in our company? That's important. And to do this, I'm sorry Axel isn't here because he's actually the star of the evening. Let's give it up to Axel for a second. Now, I want to caution you, Axel said, Jonathan, you can talk about it, but make sure everybody knows it looks like it's this way, but we haven't proven it yet. So, because I'm not getting a PhD, that doesn't matter as much. For him, it really matters. But it's a great tool, and this is Axel's work. And what he says is, there's high coherence and low coherence, local and global. I'll say what they are in a second. High coherence in a conversation is, see what Axel does, he looks at conversations designers are having, and he sees the outcomes of those conversations, and then he looks at the characteristics of the conversations and says, which ones are the better conversations in respect to the outcomes, right? And he has his own data set, and he has another data set from before, and he said, so here's high coherence. I went to the store today. The store, what did you buy? All sorts of fruits and vegetables. What are you going to make? Fruit salad. One thing follows on the other, right? It's clear. That's a high coherent conversation. For him, local means every move, and global means the entirety of the conversation. Okay? Now, here's low coherence. Now, as opposed to no coherence, right? No coherence would be nobody's answering each other. But I went to the store today. The store, what did you buy? All sorts of fruits and vegetables. Gosh, my mom isn't feeling well today. Oh, sorry to hear that. And it ends there. So that's low coherence. Okay? Now, if we were to integrate it back into it, which would be this, local disruption with global integration. I went to the store today. The store, what did you buy? All sorts of fruits and vegetables. Gosh, my mom's not feeling well today. Sorry to hear that. I know your mom loves fruit salad. I'm going to make her some. She's going to say, And that's how you bring it back in. Right? So this is an example of a local disruption with global integration. Now, what does that have to do with us? Well, this seems to indicate that there are effective ways, there are better ways to make disruptions and better ways to make integrations. So, anecdotal data suggests that the Menning conversation matrix is applicable to more than conversation. It's applicable to redesigning product service systems and making organizational change. It's likely that research will reveal steps or algorithms and more effective ways to do this in many different domains. We're looking for it right now. How does that work here? How does it work there? Now, in fact, it implies organizations need to implement mechanisms to enable these things to happen. So here's an example, the Kaizen process. Everybody know Kaizen? Kaizen is a process used in Japan for continuous improvement. And what it does is it allows workers on the line to stop the production line and say something's not working, and then they figure out what it is to fix that, and they fix it, and then the production goes on. So they're allowed to make a disruption, meaning we have to change our process, and it gets brought into the whole system, right? Another example is Google's 20%, right? Everybody know about Google's 20%? It's one of the great things. If you work at Google, 20% of your time is for your own projects. Google owns those projects, you have a piece of it, right? So Google Wallet, we're back to the wallet, damn it. Google Wallet is an example of that. It was made on somebody's 20% one day a week, and then brought back in the company and laid out, and that person got moved up the company for it. So they have a mechanism for allowing not only engagement, but for disruptions to be made, and then a way of bringing it back in. Apple's policy of acquiring promising tech and integrating into the Apple system. For example, SoundJam became iTunes, and Beats is still Beats, but it's in the Apple system. Or Roche's targeted acquisition of Genentech and Intermune as a part of a corporate strategy for growth. Genentech, we could argue, doesn't do a lot of new products themselves. They're a really good machine for ironclad, really tight development and delivery, right? So what they do is they look at startups in Silicon Valley and Israel here, different places, and they go, we want you because we can use you, and they put that into their machine, right? Another example is, so in the latter two examples, the acquired innovations constitute the disruption integrated to transform the company a little bit at a time. So, did I get that right? Design thinking can help with innovation offerings as well as create cultural changes in organizations by introducing the right kinds of artifacts, behaviors, and narratives that support innovation. So design thinking is really, really well situated to say, oh, here's a disruption, let's help you bring it back in because the way we do stuff. We're all about disruption, much more than we are about delivery, right? So, the MCM, that is the Menning conversation matrix, may be a special case of a general framework for innovation that could be applied to various innovation scenarios. And if so, I would suggest it's the Menning innovation matrix. Now, I have to say that I went to see what Axel was up to, and I saw this, and I went, oh my God, Axel, this is amazing. This is one of the most amazing. I can't stop thinking about this. I've been almost around the world, and I show people I know about this, organizational behavior people in different areas, and they say, that's amazing. That describes it. That's exactly what transformation is about, is that you've got to make these local disruptions, but you have to bring them back into the company, because if you just make disruptions and they're floating around, they don't do anything, right? If you don't have a mechanism for that, they're going to get lost. And that's what happens when people do stuff and it goes nowhere, and we've heard that again and again. So, it's very useful in how to make change for projects, products, service, and systems, as well as organizational cultures. So, this is the innovation matrix. It's a work in progress. He told me I had to do this. I think it's wise. So, what does design thinking have to do with my organizations? Different organizations require domain-relevant methods of integration as well as phase-appropriate interventions, meaning where do we make the change and how do we bring that in, right? And so research is looking into what are the effective ways of making an intervention into a disruption? What's a good disruption for this organization, right? Or for this cup, right? I disrupt this cup by taking away the handle. That means I probably can't put super hot drinks in it because I'll burn my fingers, right? But then I have to say, well, it's not for the hot drinks, it's for something else, and I've integrated into something. So, let's see. In practice, this means creating culture. And culture are objects, behaviors, and narratives. And that's precisely what design does. We create objects, behaviors, and narratives. We never, right? We know this from the wallet exercise to the noodle exercise. We're not making noodles, new noodles. Really, we're making a whole new way of dealing with noodles. We're making all these behaviors around noodles, right? So that's what we do when we tell different stories. So this is what design does, and particularly design thinking does this very well. So what does theory have to do with design thinking? Through grounding practice in empirical scientific evidence, design theory methodology provides rigor and insight, so makers of change make impactful, informed choices. Okay. Science and technology studies are necessary to talk about how this works. This is a tough one. This is one of the toughest ones for me. You'd think this would be the easiest one for me because this is what I do. I do design thinking and I have a professional practice as a designer and I do this and I do research. So this one should be the easiest. It's the hardest one for me. So I'm going to jump out and talk about research for a second and what research does. Okay? The fundamental drive of research is to create new knowledge. Right? That's what research is all about. Researchers, do you agree? It's about new knowledge, right? The fundamental drive of a designer is to create new stuff, or new organizations, or behaviors, or stories, or it's to make change, right? Yeah. And that's a kind of knowledge, right? It is a kind of knowledge. It's a dilomina is where we go with it. So what characterizes knowledge and what are the mechanisms for creating knowledge? That's a real research question, right? What are the characteristics of knowledge and the mechanisms for creating it? So knowledge is a way of making sense about the world around us, right? We have stuff in the world, phenomena, and we have knowledge about it. Traditionally, philosophers, until recently, really trouble over how this is done because, gosh, you got this thing and then you know something about it. How is that possible? Right? There's this big gap and we can't get through the gap. Now, for them, it's impossible. Now, I'm going to follow the work of Bruno Latour right here because it's really worth looking at because he's so kind of simple and it's the simplest thing he does. Simple and exact about what actually happens. First he says it's not this little gap at all. It's a big gap. But that gap actually, let's go there, actually is composed of a bunch of small gaps with things in between. And I'll show you what I mean. This is very abstract, but I'll show you what I mean. First of all, what he says is knowledge is universal, it's compatible, it's standard, it's symbolic, you can calculate it, and you can pass it around really easily, right? When you think about a research paper, right, it's very standardized, it uses a certain kind of language, and you can send it to people and pass it around. And if it's a research paper about the Amazon, it's way easier to move that than the Amazon. The Amazon's pretty hard to move around, right? Now, the Amazon itself is local, it's particular, it's material, right? That paper is material, but the knowledge is not material, we would say, in the paper. It has continuity and multiplicity. That is, the Amazon just goes on, whereas this paper just, in a certain sense, just stops right here, right? Okay. Very abstract, but I'll take you on Latour's journey. So, the research question is the forest advancing or retreating? And so a bunch of people, an interdisciplinary team, goes out into the forest to find out, this forest and savanna. This is the phenomenon, and this is the knowledge about it. It's a paper with a map. And the paper decodes the map, and these are both symbolic, and there's a lot of calculation involved in this, okay? And what he says is, if we really look, this is science technology studies, if we really look what's going on, this doesn't come out of nowhere. It comes out of all these little steps. And these little steps are, again, here's the phenomenon. And here's something we use next. It's called the, someone speak French? I don't want to embarrass myself because my mouth does not speak French. What does it say? Topophile. Thank you. The topophile. Can we do that again? I'll move my lips and you say it. The
topophile.
Thank you. I do that with other languages too. It's
anytime.
Thank you. So this is basically, it's a measurement device where they lay out string, this yellow string, and make a Cartesian grid over the jungle and the savanna. So now we have this grid that is implying itself, it's a new form, to what the ground is. And then you collect samples that are within these quadrants made by putting out this Cartesian grid. Okay. And then those samples get put into this box. It's a pedocomparator. You want to try this one?
I think I'm all right, Justin.
Really? Okay.
I think you can do that on your own.
Your voice is better than mine. That's good. So they put it in this box, which is basically a miniature version. It's containers that hold soil of a Cartesian grid, right? And there's the soil in it. So he says the earth becomes a cardboard tube, right? It's no longer continuous in the way it was. Now it's getting, you know, kind of segregating, becoming little parts. And then we get the Munsell color chart. Anybody know what that is, the Munsell color chart? Yeah. Okay, so the Munsell color chart is a standard tool that's used, it's a totally standardized tool used in industries, many, many industries, to say what color is that. And you notice it's got, well, I'll go here, it's got little holes in it and little numbers. And you take the soil sample and you put it right in the hole to see if, is that really this color or this color, which one is it? And you're holding it right up against it, right? So you do that, and then you take the numbers from that, 75YR plus whatever these that we can't read numbers, and you put them together, and that goes, colors become numbers, right? It's magical transformation. Colors are now numbers. So we've gone from the forest and the savanna to a Cartesian kind of representation, to collecting the samples, to put it in this, putting it next to a chart. Now that has become numbers, and those numbers get put into a spreadsheet, and the spreadsheet becomes graph, charts, and texts, and that becomes knowledge. And that's true for all this kind of research that's done. This is how knowledge is made. Okay? Now you might be, words become paper. Right? Stuff we say are now paper, and that stuff can be shuffled around, and it gives you a lot of power. Now, this is an algorithm for creating knowledge. Now you might be wondering, why have you told me this? And this is where the magic happens. Because I say that we can turn that around. And I say that's what we actually do all the time when we design. We go from knowledge to stuff. And a lot of us think we're doing a lot of magic with that, and it is magic, but actually, if we, right, we're going from knowledge about someone or a whole bunch of users and putting it into a thing and creating this thing, this informed phenomena, which is the Delomina. Now, these steps are the ones that I'm personally really, really interested in terms of being a researcher and design practitioner, both. Now, the steps might be too generic, but we'll need domain-specific and design-appropriate functions like this. So here's an example of taking something that looks like knowledge and making it into a thing that we can use to design stuff. This is knowledge, or it's a whole lot like knowledge. It looks like knowledge to me, and this is not. This is this other thing. And here's another example that we saw before, where we take something that looks like knowledge and we dial it back so we can get other insights as designers. And here's another example of that. Whereas we took implicitly a regular wallet and we changed it in these ways. Through research, interviews, and observations. Of course, that's just a little exercise we do, and when we do real development, when we get into the advanced track, we're going really deep on the research and we're getting it right. Right? We don't start out that way because it's too much of a burden. We get confused about what we're supposed to be doing. All right. So, what does theory have to do with design thinking? Design theory methodology is hopefully based on observing the best designers at work and making sense of their culture, what their behaviors are, what they use, and the stories they tell about it and the sense that they make. Knowledge about their, and I'll say here, your experience, can be taught and integrated into practice to the benefit of everyone. And that's what we're up to. So, back to this algorithm for designing. We'll need to make domain-specific and design-appropriate functions and even create design APIs. I know, I'll get there. I'll show you what I mean. So, which brings us, yes, we are in the home stretch, folks. How research can be made practical and bring value to my organizations. And again, this is the standard answer, but it doesn't do anything for us. So what I'm going to do is I'm going to do a Latourian gap widening and list everything we've talked about so far. So, working together, those of us in this room, we can create manageable, understandable steps across these gaps. This place, I've been around the world, folks. This place really is unique. Few other places I've been have so many people who are active and engaged and passionate and have so much depth and so much breadth. It's really a pleasure. But still, we're not doing this. If I can say we. So, in our community, as a common body, our methods are mixed. Right? Some people use what we'll say, quantitative methods, and some people use qualitative methods. Actually, we do a mix. Everybody does a little bit of a mix, but it's more heavily weighted to one or another. As we've seen, the process from phenomena to knowledge is practiced widely and well understood. Right? This is stuff, there are papers galore written on this, and they're looking at it and they talk about it. It's very, very well understood. It's what people practice all the time. However, while this process from knowledge to informed things, dolomina, is widely practiced by designers, and it has been, it's not so well understood. Right? We still have lots of questions that come up. How does that work? What is this or that? But we have to tread very lightly here because we don't want to tell designers what to do. We want to make opportunities so they can make great choices. Because the difference between, this is really going out on a limb, but one of the big differences between designing and creating knowledge is that when you create knowledge, we want a certain kind of objectivity about it. When you're designing, you really want you and you and you and you and you and you to have your say in that, to add your wisdom to it, to add your heart, your experience. And that's what makes things valuable. For example, has anybody sat in one of the Charles and Ray Eames chairs? Yeah. It's amazing, right? I sat in one after years of looking at pictures and I went, oh my God. It was one of these experiences where I felt so good about myself. Because they've got that knowledge that it's not just about here's a chair to sit in or it's a status symbol, but it's a way of making you feel like you ought to feel, right? And it's very hard to get machines to do that. You need people to teach us how to feel or give them the feeling that you have. So, let's examine a couple of conventions used in each process, and it'll show light on how qualitative functions and qualitative design APIs could be composed. Nobody's done this that I know of so far. If I'm wrong, it's okay. I had a good couple of weeks. So, matrices. We use matrices both in qualitative and quantitative work. Right? We were doing that all day today, right? How many 2x2s did we see today, folks? Right? If I had $1 for every 2x2. Right. Okay, so in quantitative practices, coordinate systems and matrices, spelling, are enlisted to handle lots of information in the form of numeric values. In engineering, we use linear algebra, which is basically matrices. It looks like this. And each of these columns represents one of these axes. And so the great thing about using linear algebra and matrices, you can have hundreds of dimensions, and you can use single equations or single functions to work through that material and make sense out of it in different ways, right? And it's all based on this. These are each points. This is a point on this, and this is a point on this, and so on and so on, okay? And what they do is they yield values which pertain to questions which are tacit concerning verification, specification, and comparison. I know it's a mouthful. What they want to know, is it true or not? Is that right or wrong? Just how big is that thing? All right? These are the questions we have. True or false? Is that a little bigger, a little smaller? Are there 6 characters in that word or 7? That's the kind of thing we do with those. In qualitative, values like crooked to straight or rough to plain are used to denote value on the axis. Okay? So here we have abstract, concrete, ill-defined, well-defined, and the insights gained through revealing new or unrecognized connections in relationship and the data set are what's important. We are not looking if something's true or false or this or that per se, but it's about relationships and connections, and that's what this reveals. And in fact, those coaches today or even designers today who were there, right, that's what it does. You go through a bunch of these. Who was it who said today? Yeah, it was James Fish. He said, yeah, you do that 4 or 5 times, and all of a sudden you start seeing stuff. It doesn't happen from the first time, but you go through it a bunch of times and you start going, oh, here it is. This is what makes sense. Okay. And insights can suggest useful and novel transformations. That is, transformations of stuff, right? Like this to this. That is, we got to move these people from here to here or this thing from here to here. They don't yield values that pertain to verification, specification, comparison, but they pose questions about how something could be different. And this is why they're valuable to us as designers, because it goes, so how could that be different? And then we as designers go, you know, that user is so-and-so, or in that situation it could be this or this or this, right? Okay. What kinds of things would happen if we changed the users and the context, the processes, the materials, or the form? These are the basic questions that we use to make change in something. You change the material, you change the thing. You change the form, you change the thing. You change the process, you'll change the thing. If you change the user and the context, you change the thing. In design thinking, this is our go-to place. In other types of design, we go here, here, and here, and here. But in design thinking, this is our touchstone because we care about people most. So, let's talk about functions. Remember functions? Some of you use them all the time. Some of you are glad you forgot them. In computer science, functions are a tool for returning numerically related values. They return something. So here's an example. It's the error function, between 2 values. You have ERF, lower, upper. Lower is a number value, which is lower limit. Upper is an optional number, otherwise it's 0. And it returns something out, which tells you which is the upper or lower of the 2 values. It's comparison, right? Functions in computer science are a tool for returning numerically related values, numbers, and strings, and different, so this is, so these are different languages. This is Python, C++, Go, JavaScript, and they say it this way, and these people say it this way, and these people say it this way, and C says it this way, but they're all saying the same thing. But the different domains have different ways of saying that because of how the languages are made. And different domains have different types of functions. So in the financial world, we have currency, things like currency functions, and it returns data from the market of the previous day close about the exchange rate between 2 currencies, retrieved remotely through it, currency 1, currency 2, and price. And this is what they are. And that's the form of a function, and it returns numbers usually, or strings that we're not cared about the quality of the string, just the quantity of the string. So what kind of characteristics and mechanisms would qualitative function manifest? How would we make a qualitative function? Whew. This is what keeps me up at night, folks. Truly, it's what keeps me up. And I don't have the answers, but I have some what-ifs about it. If quantitative functions return verification, specification, and comparison, qualitative functions could return what we call generative design questions. Those are the questions are, what would happen if we changed the material? What would happen if we changed the user? Now it's a little girl. What would happen if we changed it to be an old man? What would happen if we changed the context? What would happen if we used a new material? What would happen if we changed the process for that? And it leaves us to answer those questions rather than answering them for us, because I do not want us not in the driver's seat. I want designers in the driver's seat. Okay, so this is the change user function. I made it up. Change user function returns generative design question based on Aristotle's 4 causes. Change user. User is the character or user engaged with the project, service, or system. It returns these questions. What kind of change will we make in the context? What kind of change will we make in the form, in the process, or the materials? Just delivers this really easy. Now, designers do this all the time by themselves. Some of you say, why would we need this? Well, it has a lot of experience in it. That's why. It's a lot of clarity. It makes it really easy for me to design stuff without having to go, okay, what about this? What about that? It might be training wheels at worst. So, these are not answers, but prompts to engage designers to leverage their unique experience and insights, which is what this is all about. You're in the driver's seat. Okay. Like quantitative functions, qualitative functions would have different syntax for different communities and unique functions for different domains. So the automobile industry might have different types of functions. Function change car, function change steering wheel, function change lever, whatever it is, right, based on users and this and that. So, remember this? I told you it was the star of the show. Poor Axel. So, again, it's a work in progress. I should have put that on every page of this, because this whole thing is a work in progress. So, what if we had the qualitative disruption integration function, right? How would that look? It would look like this. Disruption integration function is a 4-step process that returns generative design questions based on Aristotle's 4 causes in combination with the dimensions of engagement. So, it's like the other one, but instead of it just being about how do you change this thing, it's about how do you change it and pull it back together, right? Because we have to go through these cycles of taking something apart and putting it back together. So, you have artifact, disruption, scenario, touch point. So depth and scenario, depth are the functions and the major form, and the touch points, and that has to do with the use case scenario, and the touch points have to do with usability, all right? So that's what the things you want to put in there. And what it returns is this: an artifact to redesign, a disruption in the artifact, a gestalt of how the artifact could be, and an articulated redesign integration. Sounds really abstract. It is, but wait, I'll show you. And I need volunteers. Can I have volunteers? Come on down, come on. 2 more. 2 more volunteers. Come on, good. I knew you'd do it. Oh, good. So I want you to be 1, 2, 3, and 4. Did you all get the right thing? Yeah. I don't want to give you my German sheet.
Give me my German sheet.
Here we go. Yeah. Hey, Leute. So let me show you what the steps are quickly. So the first one is the statement of the artifact to be redesigned. It's a 4-legged wooden chair, dining chair for adults. The disruption proposal will be, what would happen if we made it for little children? The Gestalt proposal is about the scenario in its kind of general sense. Maybe it could be very big, and that way lots of children could play on it. And the 4th one really nails it down. It's an integration proposal, which is, oh, it could be soft and cozy and low to the ground in nice colors, right? Because now we're talking about touch points with that, okay? Now, let's go through it. You want to be number 1? Okay. Number 2, number 3, number 4. It looks like this. Number 1.
Oh, it's a 4-legged wooden dining chair for adults.
What would happen if we made it for little children?
Read that. Maybe it could be very big and lots of children can play on it.
Oh, it could be soft and cozy, low to the ground, and nice colors.
Thank you very much. That is the first public execution of the disruption integration function. Now, the thing is, it could be any of these things. if we just start with something and then we say, let's change the user, or let's change the material, or let's change the context or whatever here, and somebody else does this, and then somebody else nails it as a thing. Now, I've run this exercise, and it takes a little bit of practice, and it's not meant to replace design, but watch. See this? See this? This is basically a bunch of functions in order to get across the finish line. Let's watch. There you go. Boom. Now, I promise you, this guy would have a hard time running that far down the field, which is why he threw it to that guy. Right? It could happen, but it makes it, I know it's stupid, but it's true, right? For me to be able to work well with other people, I've got to be able to know how to hand something off to them at the right moment, and it's the right thing to hand off, so they can bring it farther down the field and hand it to someone else and someone else. And this is the famous Auburn versus Texas A&M, and this is the 4 verticals play. Okay? This is the same thing. It's exactly the same thing. Now, I promise you, when these people practice, okay, folks, we're going to be running the 4 verticals all afternoon. Oh, shit, I hate the 4 verticals. But they run the 4 verticals again and again and again and again until they have it down. So when they go out and someone goes, right, here's the 4 verticals, boom, 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 and they can move the ball down the field. We don't do that so much. We do it, but we're very intuitive about it. And my feeling is intuition is nothing more than a lot of experience and practice. So we can practice these things and just run them and run them and run them. And it's easy to do this because you just do it. Let's try it this way. Let's try it this way. We're just running the plays, just like you would if you were playing scales in music or doing chord changes in jazz or playing any sport whatsoever. And everybody learns how to do this, right? They're saying what it is. They're saying, they're making the first offer. Whoa, here's a disruption. This one's going, oh, I know what to do in this. This person probably could do all those things, but it's tough. It's much easier to get this person to do this part of it, and this one this part of it, and this one this part of it, because it takes less cognitive loading, right? Just doing all this at once takes a lot of practice, but breaking it up doesn't take so much practice. I didn't make this up. I mean, I made up the form of it, but I didn't make it up. Watch what these people do. This is what they start with. They're not going to propose it, but I proposed it to them. This is the qualitative disruption, integration, function, and action gameplay. So this is, we're watching a game. We're watching the Texas A&M versus Auburn here. But instead, we're watching these guys trying to beat me. You'll see a disruption proposal, a gestalt proposal, and an integration proposal. Watch.
Looks like you can throw it over there.
Okay.
Like it.
That was the disruption proposal. She says you can throw it over there.
On a string or a...
And that also gives you gesture. Ooh, that's like the control. Like you go, like, give me that. Give me that.
That was the gestalt proposal. He's roughing it in. He's picking up the disruption and roughing it in. Now watch what the third guy does.
Cool is you can do a whole series of gestures. You can point.
Right.
And then you have a display. So this would be your display here. So let's say display is here. Maybe a couple buttons.
Let's do it again, all of us. Ooh. Right? So what he does when he does, well, should we watch it again? Yeah. Shall we watch that play again? So the third guy, what he does is, so she is a phenomenal disruptor. She just keeps on throwing these disruptions. Boom, boom, boom. This guy tends to pick them up in a very general way. And the other guy, he's a real product guy, is nailing it to here are the touch points, the button's here, the screen is here, it's like this, it feels like that, right? And they keep on playing this game again and again and again. Like I said, I didn't make this up. But we can write functions, what we would call qualitative functions or routines for this kind of thing. And this isn't the only way to do it. Everybody here has their own way, and give them to me, and I'll turn them into functions. My wife will hate you because I'll be up all night going, oh, here's a good one. Let's run this play.
Looks like you can throw it over there. Like it's on a string or a...
And that also gives you gesture. Ooh, that's the control. Like you go, like, give me that.
So what's cool is you can do a whole series of gestures. You can point.
right?
And then you have a display. So this would be your display here. So let's say display is here. Maybe a couple buttons, but then you have the different fingers. You can, I love the ability to touch or point, and then this is you're using your finger gestures.
Now wait a minute. Here comes another disruption.
Find functionality, which comes up on the display. So glove.
Bracelet.
I love
Bracelet. It could look like something else.
that. Oh, bracelet's interesting.
Bracelet.
What about bracelet with just a few connectors, so it doesn't do the whole glove?
Yeah.
You could say my Aunt married to these people and they'd pick it up and do something with it. And in that respect, so jazz is one of the models for this, right? Jazz has a lot of theory and a lot of ways of handing off just the right thing and doing things with that, right? And that's another model for what we're talking about here. There's a famous story about that Herbie Hancock talks about. He was playing with Miles Davis in a big, big venue. And it came time for his solo, and it was a completely exposed passage. He put his hands on the keyboard, and he played the wrong thing. Meaning, his hands were in the wrong place, and everybody knew it. And he said the amazing thing about Miles is that it was just another thing. And he picked that up and started making it part of the music. That's how these people are. They're really good at integrations, right? They might be better at integrations than they are at making disruptions. Disruptions are easy, integrations are hard. In fact, Niraj Sonelkar, who we all know, well, some of you know, at Stanford, his whole thesis actually discovered yes and was not the determining factor, but it was when someone blocked and someone went around that and did something else. It was all about picking it up when someone really dug their heels in, what you could do about that. All right. So that's the disruption integration function. Now we're on to APIs. Application programming interfaces allow developers and designers to look under the hood of an application. Who here knows about APIs? You could probably do way better than I could with this. I have been a programmer professionally. I did not go to well, I did go to school for it, but I wouldn't put myself in your league. So, application programming interfaces make it easier for developers to use certain technologies in building applications. By abstracting the underlying implementation and only exposing objects or actions the developer needs, an API simplifies programming. So it's a really easy way. So, okay. We use these for operating systems or things like Google Maps. They don't tell you what design, they just make design easier, right? It means that here's the custom markers and info windows for the Android Web API for Google Maps. So if I'm making an Android app and I want to get Google Maps in it, I use this code and I can play with it. There are these different things I can play with, and then they tell me which I can play with by changing the values, etc., and it can go in. It makes it really easy to do that, right? Okay, so what would a qualitative API look like? I know, you're laughing, right? This is, computer science people, do you find this funny? I do, but no. Okay, so what would one be? Look, I even gave it a name, a QD API. So, they might tell us what kind of disruptions are possible and how to integrate them. They would be domain specific. They would have certain language and functions that would be appropriate for that domain. And perhaps organization specific. Imagine an Exxon QD API, or even a Nestle QD API. How do I get into that one and interface with them, to redesign them, to jigger them, to change them? Okay. So what are the characteristics and mechanisms we would have? They would manifest knowledge, read Delomina, from a collection of stakeholders encompassing a wide range of research and practice. They could even lead to open innovation for companies. I mean, Google, Apple's closed, but they have this way of opening it up. But Google certainly is open. Linux system is totally open, right? There are all these ways of doing it. The farm-to-table food movement is an open innovation movement, right? Because people can enter, they know where to do it, it's clear. This is how I can do this, and here's how the whole system works. But all these things are very closed. But if we have a sense of here's the so-and-so API, like the digital, where are you? You. The the medical digital transform API. You can do this, right? You could do it. You could say, here are the parameters, here are the rocks to turn over. You never tell people what to design. You make it easier for them to get in there and do the designing, right? So those of you with industry, you want an API? Come work, where are you industry people? Work with me. We'll make an API for you. Okay, so how can research be made practical to bring value to my organization? I think working together, the people in this room can create manageable, understandable steps across these gaps. I certainly have not done it. I have my kind of strange beginning vision thing that keeps me up, that I go, it's absurd, but boy, there's something there, there's something there. With appropriate tools and methods, research can be translated into user-centered, domain-specific offerings. And that's what we're trying to do. That's the gold standard. How can I get that research into my business or into my clinic, right? So it makes sense for users. So, this is a remarkable and unique place. I have never been in a place that has such active, engaged community with so much depth and breadth. I'd like to replace these with arrows. And I'd like to believe this talk is going to generate some interest. This work in progress. But I certainly couldn't do this alone, and I have this nagging sensation about this, that it can be done. It's new, it's big and alluring, it's absurd, it possesses me. Let me know if you're curious. We can work together. So, with this, I wish you a Merry Christmas. I want to give you my last two before you do this. My last, where's my German notes? Annette was kind enough to print these because I couldn't. Oh. She said, make sure you say this when Professor Meinl is here. Die Atmosphäre am HPI ist einfach wundervoll. I think I know what that means, and I think it's true. And then, und jetzt lade ich euch zu einer kleinen Weihnachtsparty ein. Or, darf ich euch nun zu einem kleinen Weihnachtsschumtrank bitten?